So if you guys watched the one from last week, it's about halfway through when I realized the button wasn't green. So you get about 30 minutes of just no sound and then some sound. So we'll learn as we go, apparently. So in this case, I'm going to go up here to Visual Studio, open up a new project. I'll go ahead and grab a Windows 32 application, and I'll call this guy Chapter 4 Example. Save it wherever you'd like there. I'm going to go ahead and hit Next. I'm going to take off the SDL, leave the rest of it in there, hit Finish. And it's going to create some those default files for me. Now what I'm doing with these files at the end of the class, I'll zip this file up and I'll put it up there on under the in-class examples on D2L. So if you want to get a copy of the examples that I did, you can go ahead and grab those from there. So tonight we're going to talk about storing more than one piece of data at the same time. So far we've talked about having different data types. They can be integers, doubles, floats, characters, booleans. But currently I can only do one at a time. So what we talked about last time was having like room lengths and room widths. And we had to store those all in separate variables. Well, of course, there are times where I'd want to actually hold a contiguous block of items in one data type. Well, I can do that as long as the data types are contiguous, which means they're all the same type and they're all next to each other inside of memory. Let's say I wanted to hold a list of paychecks. So, you know, money's always good. So before, what I would do is I would just do a double here. I do paycheck 1, and then I do double paycheck 2, and then of course double paycheck 3, and I'd keep going until I listed all the items that I had. And then I'd have to keep going, and I have to refer to each one by name. So I can take that same concept and roll them up into one variable, but that variable will have different indexes. So we can roll those guys up and have the same thing look like this, where I do double paycheck, just like the other ones are. But now I'm going to use this square bracket notation. And that square bracket notation is indicating that this guy is going to be an array. It's going to hold that contiguous block of memory. And you say, well, how big should it be? Well, I have to know at compile time how big this guy is going to be. So I can put a number in between those square brackets. And that tells me tells the compiler how much memory to go grab to put in one spot. So in this case, I've got a double paycheck there. And I've got 3 items. So then once I have that, I want to actually put data in each item. I can do that by using this subscript technique, using that bracket. So for paycheck, and I say, well, which paycheck? Well, I can use that bracket identifier, or that square bracket identifier, sorry, and I can tell it which item I'm talking about. So I can offset from the first one by 0, and I can set the value in that guy. So if I'm going to use the assignment operator, I then say, all right, I'm going to make about $54.32 for that paycheck. So it looks like I need to work a little bit more. So I go out to my other job that I have, do another paycheck, and now I'll grab the next guy from that list. And that guy I made a little more, say $108. Awesome. And then I get a phone call. Uber gave me a call. Somebody wants a taxi ride. So again, I'm going to make a small little guy out of that. I'll call that paycheck. And this guy's going to be 2, and I'll make that guy, I made about $10.25, because that's all the guy had, and I gave him a ride across town. So, now instead of having these 3 individual paychecks, I now have 3 paychecks all with the same data variable name. They're all the same data type, but now I can go offset those guys by which item from that array that I'm talking about. So, one common thing would be, well, if I'm using a number 3 here, I should be able to use a number 3 on this guy. 25.34. Let's say I had yet another job. In this case, it says, okay, I'll go ahead and try and do that. But however, I said I wanted 3 of this variable type, and as you can see here, I've used 4 unique items. So I've actually exceeded my bounds. I've gone too far. However, at compile time, the compiler says, well, this is a legal statement. I've got no problems with that. I can go up there to hit the build, tell it to build the solution. The compiler is going to look at that, and it's going to say, well, depending on what checks I have on, it may be able to find that. I can actually increase the number of checks I do on my compiler and look for things like this. But in this case, straight out the box, it probably said that, hey, everything was just fine. Build succeeded. Awesome. I got to go up here to debug. I hit run. Run that guy, and boom, I get an error. It says it's a runtime error. At compile time, I didn't find any problems. Runtime, it says, hey, wait a minute here. You've got this variable called paycheck, and you somehow went outside the scope. The stack, you went outside the bounds. I have a problem. Go fix that. If I hit retry to debug, it'll bring this guy up in the debugger, but it won't because it's awesome. So go back and look and see what my issue is here. So again, we said we wanted to have a paycheck, and a paycheck is just a spot in memory, and I said it was going to be type double, and then I put a little bracket on this side and said I'm going to have a set of them. So it's going to be one or more, and when I put a 3 in here, it then gives me 3 inside of memory together. So 1, 2, 3 allows me to store some data in there. Now, paycheck happens to be this first guy. So if I want to get to the first guys, how far off from the first one do I want to be? I want to be off 0 because I want to get that first guy. So the C language is 0 indexed, which means the first guy used the index of 0. So to get to the next guy, or to be off by 1 from the first one, it would be a 1. And then this guy is off by 2 from the first one. So that's a 2. And that gives me all 3 of my items. So anytime I'm indexing an array or a sequence of memory, if I have 3 total, my array indexes go from 0 to 1 minus that number, or 0 to 2. So I have to remember in C++ language we are 0 indexed, so I'm always going 1 minus the total number. So I've actually got 3 items here, and it's indexed 0, 1, and 2. And that's why line 17 there gives me an error. Now, of course, the compiler says that's syntactically correct. That's how you would write that if you had enough. It's at the runtime that I receive those errors. So it's up to us to try and fix those as we go. I'm going to go back up here to line 17. We're going to delete out that error because, again, that error's out. So I'm going to go ahead and put a line comment. Again, a double slash means ignore everything from here to the end of the line. So that guy's commented out. And now I'm going to go up here to my first set of paychecks, and I'm going to ask the user to tell me what he received for his paydays. So to do that, I'm going to have to do some sort of cout statement. I'm going to say enter your paycheck, and then I got to do some sort of cin statement, and then I read that paycheck in. Now, of course, I got squiggly lines here. Why is that? Didn't include the header. Come back up here to the top. Go ahead and include the header to make sure we have it in there. So now I ask the first guy, give me your first paycheck. Now, I got to ask for all 3 of these. So I'm going to do a cut and paste here because I got to ask them 3 times. So give me paycheck 2, then give me paycheck 3. Seems to work out okay. However, the more that I add paychecks here, the more I have to cut and paste this same code, and my code starts getting longer and longer. So one of the advantages of having this one data type is now I can use some techniques we talked about in Chapter 2 to now actually go through each of these guys by index. So let's run this just to verify how it looks. So I'm going to go ahead and go up here to build, start without debugging. It's going to build it for me. It says enter a paycheck, 34.25, next one 23.72, and the next one is 18.23. Then it says there's all 3 of them, and I say awesome. So the last thing I'm going to do here is I'm going to get a total for those 3 checks. So how do I do that? Again, I'm going to tell the user your total pay was and then we'll do a paycheck 1, whoops, plus paycheck 2 plus paycheck 3. And then we'll do a flush and go ahead and tell the system to print everything out. So if I do that same thing again, go ahead up here to my start with that, or debug, start with that debugging, it runs. First paycheck, 42.23, 12.34, 15.20. There's our total. So as you can see, as I get more and more paychecks, it's going to be more and more lines of code. So I like to change that concept, and now I'm going to try to use this item down here at the bottom. So instead of using these top ones, I'm going to comment these out so we can refer to them later. I'm going to do a multi-line comment. So I'm going to do a slash star followed by a star slash. As you can see, they all turn green because we're not going to use those. And now I'm going to come down here and using the same thing, I'm now going to use this one data type, but I'm going to go through a loop. So I know where I'm starting and I know where I'm stopping. So the best loop for me to probably use would probably be a for loop because I know exactly how many I'm starting with, when I'm stopping, and what my increment's going to be. So I'm going to pick a for loop for this. So I type in for, there it is. And then where am I going to start? Well, I'm going to use, we're going to start out the old-fashioned way. Start out with int I equals 0, because that's what almost everybody sees. And then we say I is less than 3 plus I. And then what do I want to do for each paycheck? Well, I need to go ahead and ask the user, just like before, enter your paycheck. And then I'm going to read in. But this time, I'm going to read it in inside of my paycheck variable. And then I need to know which one to put it in, because we've got these 3 over here, index 0, 1, and 2. Well, I actually have my counter there, and in this case, what I called I. So now I can read that in this loop to find out what my paycheck is. And then, of course, once I read those all in, I'm done. How would I go ahead and find the total of all of my paychecks? Well, again, doing the same thing, I can loop through all of them. I can start from my first paycheck, go to the last one, and then I can print those back out. So, integer I equals 0, I is less than 3, plus I, and then std, or excuse me, I'm going to add one more variable here called salary, set that equal to 0, and then salary plus equals paycheck I. So that allows me to add each one of those guys together. And then if I go ahead and print that out, just like I did above, see out, you made salary. So there's a simple way to see how an array works. Again, we're doing exactly what we had at the top, except now we're doing this in a bit of an array format. I'm putting all the data together into one spot, and that allows me to use one variable name and just increment which one of that variable that I'm talking about. If I go ahead and hit debug, start without debugging, pops up, I give it some values. Made a lot more this time. I made 133. So I get the same input-output that I had before, except now I have a different set of code. So here at the top, where we had enter paycheck 1, enter 2, enter 3, and you say, well, this is actually a couple of lines less code than this is. What's the big deal? Well, let's say I wanted to have, I don't know, let's say I wanted 10 paychecks. I'd like to make a lot of money this month. So up here, what I would need to do is I would need to cut and paste each one of these items. So 7 more times. I need to add in 7 more variables. And I need to add in 7 more variables here so I could add all those guys up. Well, what we can do down here inside of our array implementation, doing the same thing, I'm just going to change this to be a 10. So now I want to get 10 paychecks. Matter of fact, now I'm going to ask you 10 times, and then I'm going to sum them up 10 times. So now with those small chunks of code, we've now expanded from 3 to 10 and just making a few changes. Now if I forgot to change one of these, this 10 or this 10 from the 3, I'd get some wrong answers, right? Well, the reason for that is these are what's called magic numbers. Because I just have random numbers throughout my code, and I have to know what they mean to go back and change them. So one of the ways around that is to not make those so random. So I'm going to come up here, I'm going to make a constant, and it's going to be an integer data type, and it's going to be num of checks. And I'm going to set that equal to 10. So now, instead of having 10 spread everywhere, I'm going to replace the number 10 with this constant. So now, even easier, if I decided I needed to have 20 paychecks, I come here to line 22, change that number to 20, and now I've got 20 paychecks that I'm going to sum up and then input. And the way I can do that is because I now don't have these magic numbers everywhere. I now have a constant that I use in place of those magic numbers. I make one change in one spot, it updates everywhere else accordingly. Any questions there? Too easy, right? So, I'm going to shrink this guy back down here. And I'm going to go back down to having just 3. Reduce that back down to 3. Again, one easy change, and now I have 3. And I'm going to comment out my enter paycheck. So now what I'm going to do is I'm just going to add up whatever I have here in paycheck. In this case right here, I've initialized paychecks. The first one to be this one, the second to be that one, the third to be that one. I should end up with the total. I can verify that by going ahead and hit start without debugging. It runs. I get 172. I say awesome. Well, what would happen if I forgot to give an item a value?
It'll be 0.
You would hope so, right?
Or whatever random spot in memory it happened to be at.
Exactly. So that what we hope for it is to be 0. If I was in a type-safe language like Java, C#, those guys actually initialize your values for you in case you forget. So they give it 0, null or false. C++ doesn't quite work that way. C++ puts you in charge. So if you decide to not initialize those variables, it doesn't do it for you. So inside of paycheck 2, I hope to get 0. It might be something else. So if I run this again, let's see if I get 162. It might be close.
No.
Really close, right? Not even, right? Negative 9 times e to the 61st power. So that's a pretty big negative number. So, and the reason for that is I never initialized the value inside of 2. Well, there's actually a different way that I can define my paychecks, and I can do that with what's called an initializer list. So on line 23, I'm going to say equals, and on the same line, I'm going to initialize what I want my values to be. So 54.32, let's see, 108.32, and 10.25. So there's my initializer list. And so since I've already defined it on this line, I'm going to comment out those lines. Because again, I really don't feel like doing it twice. So now I've got the number of checks, and I've got initialized. I do that with a curly brace, and I separate my values with commas. I need to make sure that my number here does not exceed my number of checks, or I will end up having a problem on that one. So now if I go to start without debugging, I get a much smaller number than -9 times e to the 61st power. I now got what I expect. So here's one of the other key items, is let's say now I go to 5 checks. What do we expect this code to do?
Yeah, the last two will be 0 now.
We expect the last two are uninitialized. I didn't initialize them. So what's going to happen here? Well, because we have an initializer list, it now says, well, since you started initializing these guys, I'm going to be nice and help you out and make the rest of them 0. But that only happens when I have an initializer list. If I leave this blank and start doing it individually, I don't get that same feature. Sir?
You wanted it to all initialize to 0, then you could just initialize the first to 0 and let it initialize everything after that to 0?
Correct. But what you don't want to do is assume that if I initialize the first one to 2, that the rest of them would be 2. It doesn't. It resets them to 0. So as long as I initialize one of them, and of course in here I have to initialize the first one in order, and so as long as at least one of them gets initialized, the rest of them get filled with zeros.
So if that 2 wasn't there, would they all be 0?
Should be.
Oh, so you could initialize it to blank and it's all 0s.
Because as long as there's an initializer list there, it says, oh, you tried. I'll take care of the rest of them that you missed. If you happen to miss them all, he takes care of them all for you. So, questions there? Again, you saw what happens when I only have one. I get junk data. It's called garbage in, garbage out. So once I start getting garbage in there, I can't ever get rid of it because I just keep carrying that junk on through all my calculations. So, one more thing to point out here while I'm on this is, since we're printing out money here, I'm going to hit the undo key a couple times, bring us some money back. I'm going to go ahead and print this guy out with a precision. I want to go ahead and set some precision on this to make sure I get 2 decimal places. Who doesn't want at least to see all the money, right? So in money, we want to have 2 decimal places. How do I force the compiler to give me 2 decimal places? Well, I have to include yet another item that's called IO manip. It was talked about in chapter 2, and they kind of skipped over it really quick. But IO manip stands for input-output manipulation. So if I want to manipulate the input-output stream, it's going to be found in IO manip. So now in here, before I print out my salary, I can now do a set precision, std : set precision, and it says, well, how precise would you like to be? Well, please print out 3 decimal places for me. So in this case, we're now required to print out 3 decimal places for those double numbers. And again, if I want to see that, I go ahead and hit start. It's going to compile it for me, and then I got 173. Is that what I expected? Probably.
Not what you intended, but it's what you
Exactly, right? The computer did exactly what I told it. So now, I've got to go ahead and tell it something additional. Because yes, I got 3 columns of data, but because my numbers were larger, I got the whole numbers. What I really wanted was decimals, right? So now I have to modify this and go, yeah, we're going to do 3, but now I need to tell you some additional items. So now what I'm going to do is I'm going to do an std : set iOS flags. And set iOS flags allow us to tell it some specific items. One of those is going to be std iOS, and this one's going to be fixed. So what I want you to do is I want you to fix and show me the same amount on every number. And So I'm going to use the OR option with this. What I also want you to do, stdios : and it is show point. So if you have a number that happens to be a whole number and it doesn't need decimals, show me anyway. So do this without even asking. Show me some decimal points. So now I'm modifying this stream and setting some input-output stream flags and saying, hey, I want to make sure you show me a decimal point every time. And when you do, I want to make sure that they're lined up appropriately. So now if I do start with that debugging, it pops up. Now I get 172.890. I now get my precision after the decimal point. In this case, I went to 3. That's what I asked. And even if this number didn't have a value for the third one, it put one in. You're going to at least get 3. So just to see that in a different way, if I change this to where these were all zeros, and I wanted to get 4 decimal places, just to see. And there you have it. I ended up with 172. I didn't have anything remaining, but we told it, show a decimal point. When you do, I want you to make sure you show 4 places on your precision. So even though you didn't need to print one for me and go to 4 decimal places. It talked about that in Chapter 2. It kind of had a very small little blurb in the corner. So there's how to do some set precision. Questions there? So, just like with doubles, I can do the same thing with any other data type. So I can change that to integers. I can do that with booleans. I can do that with longs, shorts, all those other ordinal and floating point data types. So the next question is, well, what we haven't talked about was characters. So if I like to hold a character, what is it that I would do? Well, I'm going to come down here to the end, and I'm going to put character C equals J. So there's one character. Well, if I wanted to spell out my whole name, I'd have to put like character C1 or C or D equals A, character E equals R, and so forth, and that kind of gets old, right? So I can take the same concept of arrays and apply that to characters. I put more than one character together, I end up with what's called a string. So using that same concept, I'm now going to have a character array, and I'm going to set that equal to, in my case, I'll use Jarvis. Feel free to use whatever items you like. And matter of fact, I'm going to cut this out and paste it above that line. And I'm going to add that into my string. So now I'm saying you made, I'm going to say Jarvis made. Or in your case, whatever hopefully unfile language that you put in there. So again here, I can go to debug, start without debugging. And now it says, hey, here's your name. You made that much. So that's how we can actually take individual characters and put them together into a string. So in order to see a potential problem, we have to see how it's written. So just like here in double paycheck, I can do the same thing, except now I'm going to say character, name, and let's say I don't know how big it's going to be yet. So what I'm going to do is I'm going to say equals, well, because I can just use quotes and just put the word hi, H-I. So what's that do in memory? Well, it grabs a block of memory, and there's where our name is. And then it says, well, all right, I got the first character. I'm going to call that H, and then I'm just going to write my characters in there that I have. H-I. However, the question is, where does this string stop? How do I know when I'm done with this string? If I just go to that spot in memory and start writing characters, how do I know when that character ends? Well, that's where we get into what's called a null terminated. So every character string inside of C, or a char star string, ends with what's called a null character, or a /0. That's one character. It's an ASCII term, I believe it's 13, which says this means that as you're looking through this name, you hit the end. So in this case, this name, which I've allocated HI, is actually a length of 3. Because it not only has the H and the I, but it also has a /0 at the end. So it adds that in for you. So I can do that. Just like here on line 41, I've got JARVIS. I assign it in there. In this case, it happens to make it the right size for me and adds in that /0 at the end. But I could do something silly. So if I commented out line 41, and I just said character C bracket 6, and then I put C0 equals J, and then C1 equals A, and I kept going like that and filling it in. I could then go to start with that debugging, and then I get that, which I'm sure is exactly what we wanted. Because in memory it says, hey, start here at the J and start writing out that string until you get to the end. Well, in the string that I made individually, did I put a null character in it? I didn't. So it just keeps reading in memory until it finds a null character. And in this case, it read way more than just the 6 that I had allocated. So, and when you use a C-style string or a character string, we have to make sure that they are null terminated. So, in this case, if I wanted to use this, if I just add in that /0, which is my terminator to say, hey, this string ends. So even though it has enough room to hold 6, I'm going to end a little bit early here. Now when I go to run this, I should just see JA. Because again, we ended that string, so it knew where to stop. Questions there? All right, so this is the C style of doing things, or character pointers, pointers to characters, the way we did it in the C language. C++ realized how many problems everybody had with these character pointers and said, well, I'll give you a different solution. So what we're going to do in here is they made an include for a string, and it's just called string. This is part of the STD namespace, or the standard namespace. So in this case, STD string, and I would put my name.
So C didn't even have strings?
It had characters, and then it had multiple in a row. So what they were called is they were called char star strings, which are character pointers to that which were strings for you. So C++ said, I see all the problems everybody's having with these character pointers, not having the right null terminator, running out of memory space. So we're going to have this standard library with a string and have my name. So now in here I can say my name equals Tommy. So now here my name's Tommy, and then again to print it out, just like I would any other data type, I can put my name. So again, if I run this, I should get to see that Tommy made all that money and not me, unfortunately. So now Tommy made 172. Awesome. So there's our example with a character string. Now again, this string class takes care of the null terminator. It takes care of allocating the right size to hold it. It takes care of those things behind the scenes. Better for you, right? So if that's not awesome enough, CLR added its own string class. Because again, CLR, Common Language Runtime, it's got a few requirements in the background. So it's going to use something called system and then C string. So C string is how you're going to use a CLR object. Now, what's the reason that this guy's got a curly line under it?
I'm not in CLR.
Because this is a Win32 app, right? So I don't have the right headers up there to see a C string. So we'll have to see that when we get to our CLR example on Thursday. But that's how we would do a string inside of CLR. So I'll comment that out for now, and I'll even make a comment here and say, this is for CLR. That way we have a reference for later. So I've got these characters. I can make my own. But what if I want to ask the user, hey, give me your name, and I'll add that in. So if I was going to do it the old-fashioned way, I'm going to start off doing this in a C style. So again, I'm going to go ahead and ask the user, enter your name. And then if I did CN, I would need to put a data type there. Well, I can't put this array of data. I can only put a data type. So in this case, I would have to read in one character at a time. Well, nobody likes doing that because you could have a long name. I don't know how long your name is going to be. So what we have is we have a get line. So instead of using your extraction operators, hit the dot or the period or the member operator, and in here you should see a get line. So if I scroll down, there's my get line. I can tell it's a member function because it's got the box around it. So I double click there on get line, I do my open parentheses, and then it tells me the two different things it's looking for in order to do a get line. So the first one is the character pointer on where the string is going to go. So I'm going to put that inside of C. Then the next thing it asks is, how many should I read in? What's the maximum amount that I should get? Well, in this case, what is the maximum amount that I should put there?
Whatever you tell it.
Well, if I give it more than 6, what's going to happen? I'm going to have some memory problems, right? So I need to make sure that I tell it, hey, don't get more than the amount that I can handle. So in this case, I could give it a 6. If I gave it a 6, what would happen if I gave it 6 characters?
That's /0 at the end.
It'd try to put that null terminator at the end, and then I would have another memory problem. So I got to make sure that I tell it, hey, you can only take 5 because I got to have space for that extra null terminator. So in that case, I would read it in, and then here I could say C, print it right on back out, and let's see what we read. So if I go over here to start without debugging, it compiles, it says enter your name. I'll say John, it says, hey John, you made 172. Awesome. Let me run it one more time, and this time I'll give it a longer name. And now it'll be Jonathan. Like to be formal here. I hit enter, and now it says Jonna. Why is it J-O-N-A? Well, it's the first 4 letters. And then CN said, well, just to make sure you don't mess it up, I'm going to add the /n on the very last character. So it actually eats up the last one. So what I really need to do is say how many actual characters that I can get. And then it will only read in 1 minus that to ensure that you get your /n, your /0 on the end. So in this case, I now change that to 6, run it again. And now I type in Jonathan, and I get J-O-N-A-T. Because again, the max I can have is 6, and CN eats up the last one you give it with that /0 to ensure it's null terminated. And I say, well, thank you for all that. So that's how I would use CN to get a string. I'm going to read in a line, and I'm going to say, hey, here's my character I'm going to read in, or my array of characters, and that's how many, the max that I can grab. So that's how we do it with a C-style string. Now let's say I had my name here. So I'm going to comment out this line. And I'm going to say, okay, so if I tried that again, so if I did cn.getLine, and this time I'm going to do my name. And then how many do I want to grab? What's the max? Well, not sure. Let me just put 15 for now, see how it works. Type in 15. I then go ahead and go to hit build. I think, oh, this guy's going to be great. And then down here, boom, I have some errors. And I go, well, what is your problem? Come down here and it goes, hey, wait a minute here. I tried to use this getLine function here. And getLine itself takes a character string or character pointer, but you pass it this std string, and I don't know how to deal with that. So you say, oh, okay. Well, since std string provided this awesome string class, it understood that you were going to have this problem. So the std string class also provides a getLine. So instead of using the old C style, I'm going to comment out that line. And now I'm going to just do std : getLine. And now this is actually part of that string class, or that string header we included. So now when I use that guy, I hit the open parentheses. Now here's the things that I can pass to it. And again, I've got 4 different options. If you hit the up and down arrow, you can scroll through those to see what you're looking for. If you understand how to read these system headers, this would make sense to you. Probably doesn't at this point. So I'm going to tell you what you need to write in there. So the first item is going to be the actual stream you're trying to read from, followed by the where you're going to store this data whenever you're done. And that's all I have to have. Now there's some other options there. So let's say I only needed 2 options. Then I look at my item and go, all right, I got a squiggly line. What's that mean? If I don't know what it means, I can always hover over it. And it says, wait a minute, getLine doesn't just take those 2 arguments. So what's my problem? I gave it the 2 arguments I needed. Any ideas there?
You need to have std : cin.
The problem is it doesn't know what cin is. And it says this getLine function doesn't take I don't know followed by a string. It takes an actual string. So once I fix this error, std : that one fixes this error. So now, again, I can start without debugging. It compiles. Enter your name, Jonathan, and then I got JA again. What happened there? I still need to update my cout statement to now do my name. And now that it says my name, I should get the whole name that I typed in. And now I get Jonathan. So somebody might say, well, what if I want to type my whole name in? So let's say I did, whoops, Jonathan Williams. There's my whole name. What getLine does by default is it reads from this string, or from this stream, into this string until it hits the end of line. So it will read that whole line in. I can change what I'd like to read in if I pass it an additional parameter. So if in this line I passed it a quote and said, hey, read until you get to either the end of line or the next space, I can then read it in by strings, by string tokens, and not the whole line at one time. So if I did that example one more time, start without debugging, and now I type in Jonathan Williams, ensure I have a space in there, and now I just get Jonathan because it found that delimiter and said, oh, I'm supposed to stop now once I find that first space. So you just got back Jonathan. Questions there? Awesome. All right, so now we have a way to read in a name. We've got a way to read in a set of strings. I can do that either in the C style or in the standard library style. So the next thing I'm going to do is I'm going to expand our ability to use these arrays. So what we've done so far is I've got a one-dimensional array, which means I've got one item there, and I say I'm going to start at this point in memory. I'll offset however many I have, and then I'll have just this one big list. Well, that works out great. So you start talking about things like a spreadsheet. So how would I implement a spreadsheet? A spreadsheet not only has a row of data, it's got multiple rows of data, each with their own columns. So now I've got rows and columns. Well, inside of C++, I can easily implement that because I can use a more than one dimensioned array. So I'm going to comment out line 53 so it doesn't ask me for my name every time. And then we're going to come down to the bottom and create a double dimensioned array. So let's say I was not only getting paychecks, but I was getting them from different companies. So company number 1 might be Starbucks. Company 2 might be Rose State. Company 3 might be Grandma Loves Me. Maybe it's that category. So I've got these different people who are giving me different paychecks here. So I could do that by doing a double paycheck. Now, if I leave it just paycheck, this will clash with this variable name. So they have to be unique. So I have to make sure I give it a unique variable name. If I use paycheck check 2, well, what's going to happen? I already got one, right? Make sure they're unique. Paycheck. Let's call it paycheck array, just to be confusing. So I've got paycheck array. Now to declare an array, I just do a double bracket or a double square brace. But to do a double dimension array, I just add another square brace. Now, if I put a semicolon there, the problem is it doesn't know how long each of these dimensions are. So I've got to go ahead and tell it, how big do I want this to be? Well, let's say I want to make a 3 by 3. So it's got 3 rows and 3 columns. And to draw that out, it makes it look easy on the board. So I've got this table of data. These are my rows. Row 0, row 1, row 2, column 0, column 1, column 2. And again, I use this first index as what row I want. I use the second index as what column that I want. So if I want to get into that array and I want it to get to this cell here, so again, that's column 2 and row 1. So to get to that guy, on the next line, I can just put paycheck array. And that would be column 2, or row 1, column 2. Now, if I do it that way, what is inside of all the other ones that I didn't just assign a value to? So this one's where I give it 10.54. What's in everything else? Junk, right? Stuff you probably don't want. So what's the way to get around that? Give it an initializer list, right? So in that case, I'm wanting a 3 by 3. I don't give it anything. It fills everything with the default, which is 0. And then I have 0 in everything, with my exception of this guy that has 10.54. Now I can also make this a little bit more dynamic. If I comment out line 57, I can actually type inside of my initializer list what each row is going to look like. So I'm going to tab over just to make it look clear. So I can say my first row of data is 1223, 1456, 16.23, whatever you like, comma. What's my second row going to be? And I can fill in my data and initialize it by using an initializer list inside of an initializer list. So I'm defining it per row. C++ is row major, so it always starts with the rows first. So the first index is always the row. So let me give it some data just to put in here. So in this case here, I've got 3 rows of data. And then I've got 3 columns of data. So now I've initialized my array. Every item in my array has data in it. So what you can do past this is, if I'm going to give it an initializer list and tell it how big each dimension is on each row, I can then remove and not have to specify how big these are, because my initializer list would take care of that for me. However, I still get a red squiggly line. You can't really see it because it's trying to underscore an error that you can't see right now. But if I go ahead and go to build and look at it, it should give me my error description. Should come back and say, you're missing a subscript. And the reason it's missing a subscript is I don't know how to break down how many you want per row and how many per column. So I have to at least tell it, one of them, how big my last dimension is. So if I tell it how big the last dimension is, it can then calculate what the other dimension should be based on your initializer list. So I can leave the first item blank and do the rest. So that's an important thing to know once I talk about the next topic of going to another dimension. So I got to make sure that I can leave my first one blank, but I got to tell it how to divide these up. So I have to give it the number of columns. Questions there? You build it, get rid of that error. All right, so if I had this I've done a one-dimensional array, I've done a two-dimensional array, why couldn't I have a three-dimensional array? Well, I can. All I do is I add another bracket and then tell it how big it is. So now I have a three-dimensional array, a 3 by 3 by 3, or a volume of things. One way to look at it would be, I've got rows and columns on a page, and then I have a number of pages. Well, I could have this as be the columns, the rows, and the page number. Well, I have multiple pages inside of a book. So I could add another dimension in there and say, hey, this is a row and a column on a page in a book. Well, if I put a bunch of books together, I end up with like an encyclopedia. You could add another dimension. You're not limited by how many dimensions you want. You just have to specify how big every dimension is except for the first one. Sir?
So, this makes sure. You just counted backwards as an example because you said rows or reverse.
So I can specify which one of these guys does what for me. So I can say that this column here is going to be my columns. This is going to be my rows. This could be my pages. This could be my encyclopedia sets.
Okay.
I could label them the other way. It still holds the same amount of data. I just I access it in a different way.
Okay.
So it's up to you on how you're going to design that out. Sir?
How would you access the third dimension? Just use variables and loops? Or
Just like you would access the second and the first dimension.
just plug in the number?
Just like up here, I did one for loop to go through one of them. If I was going to do a two-dimensional, it'd be 2 loops. 3-dimensional, you end up with 3 loops, and then so forth and so on.
The main thing that was messing with my head was initializing. Because I'm sitting here going, I can see initializing row by column.
Yep.
Cannot see initializing row by column by page.
So in this case, I would need to, so this is a 3 by 3 here, right? So if I put that inside of a one item, this would be my first item of this 50.
Okay.
I now need 49 more if I want to initialize every one of those guys. And we haven't talked about how many is going to go in this dimension. So again, you can have as many as you'd like, as many as you think you can manage. The most I usually see is 4, but the world is your oyster, man. Go get them. Do as many as you like. But that's how we would do a multi-dimensional array. So I'm going to reduce this back down to something a little bit more manageable. So let's just go back to a 3 by 3. Now because I've got all these extra curly braces in here, now it says this guy shouldn't exist. I've got a set and a set and a set. You should only have 2 subsets here. And that's why I got the squiggly lines. So again, I say, yep, you're right, my bad. Go back and get rid of those guys. And now we're back to having a 3 by 3. Sometimes when you write it out like this, you can see your columns line up. It makes a little bit more sense. I'll even actually add extra spaces in here, so I'll put to where they all line up. And that way, it's clear and makes a bit more sense. That way you can see, here's my rows, here's my columns. And again, anything I don't label gets filled with a default value of 0, null, or false, depending on what kind of data type it is. In this case, they'd be all zeros. Yes, sir?
In your professional life, do you use a 3 or 4 dimensional array terribly often? It seems like you're making database software almost.
Yeah. So what I'll end up doing is we'll have pointers to pointers to pointers, which can be treated like arrays to arrays to arrays. And that's what we're building up to here. This is really just pointer arithmetic. So we're getting there. Yeah. We're getting there. Building up to it. Questions there about a 2-dimensional array or even a multi-dimensional array? Again, they kind of hint at it there in the book, give you one example and move on. So I want to make sure that we saw what was going on there. So just like this is a double, I could do the same thing with a character. So let's look and see what that would look like, because we're going to need that again in a minute. So if I had a character and I had a name list, and let's say I did a double dimensional. Well, what would that be? Well, that would be an array of character strings. So in this case, if I wanted to initialize this guy, I hate that it goes all the way over to the left. So the first one I'm going to put is Rose State. The second one I'll put is Midwest City. Third one I'll put is Oklahoma City. And I'd be doing them wrong if I didn't say Edmond. So in this case, I've now allocated enough memory to hold strings of length 50. And in this case, I'm declaring 1, 2, 3, 4 of them. So now I've got a double dimension character array in which the name list, the first bracket is what row that I'm on. So that would be either Rose State, Midwest City, Oklahoma City, or Edmond. And then 50 is, they're going to be a length of 50. So this is going to be square. But even though I only used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of those, I've got allocated enough for 50. So I can actually make that string longer up to 49 characters plus a /0 because we're using characters. So in this case, if I wanted to print those guys out, it would look something like this. I know I'm going to go through every item in the list. I know where I'm going to start and stop, so I'll use a for loop for that. So I'll do for integer I equals 0, I is less than 4, plus I. And then in here, we'll do a std cout name list. And then I really just want to print out, starting with the first character of every string. This will print the string out and stop when it hits the /0 or that null terminator. So in this case, I can go from the beginning to the end. And let's see what this guy's, any idea what this guy's complaining about? Well, what is it?
Missing semicolon.
Semicolon, right? I got a statement up here, in a semicolon. The error ended up on the next line. It says, I got to this point and got confused, and I bet if I go back to my error list, it'll give me a hint. It'll give me a hint and go, hey, at this point, I found a for loop. I didn't come across a semicolon yet. So you go back and look, go, yeah, you're right. I forgot to end that statement with a semicolon. Now, of course, I get a semicolon, everything's all better now. So start without debugging, and there's my 4 of them. Rose State, Midwest City, Oklahoma City, and Edmond. Press any key to continue. And of course, if I want to make it look any prettier, I could add in there an escape sequence, which means go to the next line. So now we'll get each string on its own line. I can actually see what's going on there just by adding in that escape sequence. Those 2 characters is actually one character together because it's got a backslash. It's being escaped, which means it's special. And that's how that guy's getting printed out. So let's say I want to do something crazy, and I'm going to give it another value after the first one. So what would this do?
That one should print the 3rd letter of every word.
Right? So let's see what that looks like. Start without debugging, and there I get EWAO. You go, man, that makes no sense. Well, I need to go look at my numbers here, and the 3rd index is offset 3 from the beginning, so that's really, here's the beginning, and I go 1, 2, 3, so it's really the 4th one over, and that's how I got the E out of Rose, the W out of Midwest City, the A out of Oklahoma, and the O out of Edmond, because I offset over to that one. Questions there? Because again, I didn't print out the whole string because now I'm saying go to that character. When I didn't have that, I went to the pointer or the address to where that guy started. It printed out till I got to the /n. Once I gave it the 2nd bracket, it says go to this specific character and print it out. Questions there? Too easy, huh? Awesome. So the next step, or the next iteration after this is, well, I've got this spot in memory. How would I know where that spot is? Well, I can have a data type that's actually a pointer to a spot in memory. I can do that by using the pointer operator or the indirection operator. So if I had a character pointer that pointed to a character, it would look like that. So now what I've defined is I've defined a data type that points to a character. On this case, if you read this backwards, it makes more sense. So character pointer points to a character. Okay? So let's say pointer character equals D. What does that actually do? Well, as you can see, I've already got a problem there. It goes, I'm not really sure what to do with this. And you say, well, why not? What's the problem here? Well, I need to point to a spot in memory. After this line, what happens to this quote D? Goes away. It's what's called an R value. Your book calls it an R value. They talk about that at the end of chapter 4. An R value is I use it temporarily, and then it goes away when I'm done. So if I was to set this character pointer to this temporary variable, on the very next line, I wouldn't be pointing to anything good yet, because it goes away. So I need to make sure my pointer is actually pointing to something that's inside of my memory. So in order to see this, instead of having it point to a temporary value, I'm going to have it point to namelist 0. And now it's pointing to the character that is in namelist 0. So I've got this double-dimensioned character pointer list. If I grab my marker here, it looks like it goes out to, say, ... column 50, and then ... we're doing row 4. That's not really ... So row 3 there. So that's currently what's inside. That would be what would be inside of my memory locations. And it looks like that name list there starts in this spot. So now what we said was we're going to take name list 0, which is here, because that's the first row, and we're setting that equal to our character pointer. So let's see what it looks like. So to do that, I could do an std cout. And what I want to print out? Well, let's just print out character pointer and see what it tells me. And I'll give a /n. That way it's on a line by itself. We can identify which one it is. So now I hit run without debugging. I think it's like Shift F5. Nope. Control F5. I was close. So now I got EWAO, and then I got row state. Is that what I expected? Yeah, right? Because again, I'm pointing to the R, and because that's a character pointer, I keep going until I find the /0. So, what happens if I did something silly and said, print out star pointer, just like it says I defined here? Well, what's that going to print out? Memory location, right? So I go up here to debug, run it so we can see it. Of course, it compiles fine, and I get an R. Why did I get an R?
I was actually expecting a negative number.
Yeah, so some crazy number. Yeah, to put an X or something.
Right, so why did I get an R?
Well, that's what's in that location.
That's the first one.
Right, that's what's in that one location that I'm looking at, and that's what I asked for. Hey, go to this guy and dereference that string and give me the one guy that it points to. Because I'm really just pointing to that R. But the cout statement says if I just give it a string, it prints it up to the /n. So we've modified what we're asking for by using that dereferencer and say, don't give me the whole string, give me what's at this address. So I get a star. Now if I wanted to see the actual address, what would I do? Well, I could use what's called the address operator. And say, all right, give me the address of where this character pointer's at. I run that, and now you'll get what you expected and get the memory address. So 0021F5EC. Hope that means something to you. Don't mean anything to me. So that's how I get the actual address of where I'm at using the address operator. So I've got the indirection operator, which is the star, and then I've got the address operator, which is the ampersand. So one gives me the dereferences. The other one gives me the address of where it points to. Questions there? So one way that we can use this item is I can actually point to another variable. So I'm going to jump over these, and we're going to add a couple more lines of code here. And in this case, I'm going to have an integer. Data equals 12, and then I'm going to have an integer pointer, my data pointer, and I want that to equal to what's inside of data. So most people would say data and call it done. Now the C# compiler or C++ compiler gives me a hint and goes, hey, that's really not going to be what you want. On some other compilers, it'll let you do this because it's syntactically correct. This guy's telling you, hey, you might have a problem here. So the C++ compiler is going to help us out and go, hey, wait a minute. You're trying to go from integer to an integer pointer, and I'm having a problem doing that conversion there. So what I have to say is, since you point to an integer, I need to get your address. So to get your address, I'm just going to use that ampersand operator. So now we're saying that my data points to an integer, and it points to the address of what's inside of data.
How does that give you an advantage over just using data? Because one's pointing to that location and one's just that location. Why not just use that location?
So what we've done right now is we've made what's called an alias. So let's say right now I want to do cout, and I'm going to print out my data pointer. And of course, let me go ahead and add in a /n. That way it goes on its own line. Maybe. So now in this case, I don't mess with what's in data, but now I can print out what it is because now I have an alias to it. I can see exactly what that guy is. I get 0262F66C, so I'm on a different memory location. So now I want to dereference that guy and go show me what's inside of that pointer value. So I go, okay, let me see it. Print it out, and I get a 12. Okay, so now I can see what that guy is. So now I'm going to do data plus equals 15. And then using the exact same statement, oops, I'm going to print out my data pointer again. I haven't messed with my data pointer, so I would expect it to be 12 just like it was before. So if I hit start without debugging, now I get 27. Why is it 27? Because I'm pointing the same address as data is, so when data increased, so did I. So now what I can do is we can now link together our data. So I'll control the data, and you just point to it. And then as my data updates, as I'm doing my own thing, you can grab the data that I have without asking me again. Because now you have access to it. So now you have access to the updated data that I'm updating without even asking. Because you made a reference to it. You've got your own pointer to it.
So this is useful if you're doing a program that's communicating with the server?
Oh, most certainly. And we'll see how it works even between functions. So if I got multiple things going on at the same time, you have control of the data. I can see what you're doing. I can make an update if I need to. You make an update if you need to. But we really have the data living in one spot. Because the problem you have with multiple copies is, well, when you make your update, then you got to tell me that you updated it. I make a copy. I update it. I got to tell you. You make a copy. So we're getting rid of the copying by going, hey, we're going to look at the same sheet here. So either I have the pencil or you have the pencil, but we're all going to write in the same spot.
Less memory then, huh?
Oh, yes. A lot less. So, questions there? That gives about this much in the pointers, and we'll spend the next class getting the rest of the way through it. All right, so I will zip this thing up, put it up there as an example. We'll start here next time and keep going with pointers. I added the quiz for this week, so it's in there. Got to get it done by like Sunday. Too easy. What I try to do on the quiz is cover the things that we didn't talk about in class that the book covered. So just try to reinforce that you actually read the chapter and you got an idea of what's going on. I hope to have your Project 2 up by Thursday. That we guys can get started on it for you overachievers. All right. See you on Thursday.